And here are some more analysis methods for measurement errors. One is a calculation of reliability coefficients. Basically, these are coefficients based on you get these reliability scores. These are measured by the same examiner at multiple time points. So this is interclass correlation coefficient. So you can look at maybe a bias from having the same examiner, or you can have inter-rater reliability. And here you have different examiners, and you can look at the reliability of values based on having different examiners measuring the same thing. And the coefficients can range from 0 to 1, with higher values indicating greater consistency. Another way to look at measurement errors, you probably all have heard of this in statistics, this minimally detectable change. Basically, this is the smallest change between a control and a treatment group that can be distinguished within the limits of the measurement error. So each instrument has its own measurement error, and hopefully that is much smaller than the actual variability in your data. So you can actually detect differences between control and treatment groups. So this minimally detectable change is the smallest change that can be distinguished within the limits of your instruments. And this is the actual change, and that's not due to the measurement error. And this can be calculated using the standard error and confidence intervals. And finally, if you have two different instruments that you can measure the same thing, one recommendation is to do a Bland-Altman analysis. And this is just a simple difference plot. And it's used in analytical chemistry or in biomedicine. So basically, this is a sample data from two different measurement methods on the x-axis. And here they're looking at detection and movement of events in speed skating in the left and the right shoe of speed skaters. And these are really good data because this is a plot of the difference between the two measurement methods. One's on the right foot, one's on the left foot, and the difference is essentially zero. Most of the data clusters around zero, so there's actually no difference. There's very minimum difference between using two different measurement methods. So that's one way to visually capture the error between two measurement methods. So this is commonly done in biomedicine or analytical chemistry.